Hi everybody, Wes Boss here. We are going to make a photo booth with JavaScript today. Now, first of all, if you see like I'm talking and then later on the audio doesn't add up, that's because I'm recording my screen on a 4K monitor and piping video through, and it's just too much. So when I stop recording my screen, this is live. Don't worry if you wonder if the sound is off or not. So what are we going to be building today? We've got this. First of all, we've got our video being piped in from our webcam, and then we've got our video being piped into a canvas element. And then once it's in a canvas element, we can start to do all kinds of cool things with it. Like we can take our photo, and then you can go ahead and download them, and they'll download to your computer, and you can see them as real photos, handsome.png. And then in these scripts, once we have it, we can start to add effects like different filters where things should be red. Or what we can do is make this really cool RGB split where you can see, like, you see my face. Don't look at the top right hand corner. I look crazy, but the RGB values are just a little bit off. You can play with the alpha. So it's just a bit of like a woo ghosting effect that goes on here. And then finally, the green screen. If you've never known how to green screen works, essentially you pick a color that's in the background, and then you find any color that's like within the range of that specific color, usually green, and then you pull it out. And whatever is behind it, like a video or a beach or something like that, it's going to show. So we have these slider values here, which we can use to discover what the threshold is. And in my case, I'm just pulling out just a whole bunch of stuff, but you can do some fun stuff. And whatever would be behind that would then show on through. So this is going to be a bit of a big one, but it's going to be fun. So let's get rolling. I'll open up my index.html and switch the scripts finish to just scripts.js, and we'll go into our scripts.js. Before we get started today, there is one thing that we do need to get up and running, and that is a server. So far in this course, we've just been working off of the file. We right-click and open that sucker in the browser. However, because of security restrictions with getting a user's webcam, it must be tied to what's called a secure origin. And a secure origin is a website that is HTTPS, or in our case, localhost is also a secure origin. Even if it's not, has a little icon lock there, it's still considered a secure origin, which is localhost. So what I need you to do, if you take a look at it, so we have this index.html, that needs to be fed through some sort of server. So if you've already got some sort of Python server, or maybe map if you've done WordPress, or any sort of local server running, you can totally use that. Just make sure that you feed this index.html through your local host server. Now, if you don't have any sort of server locally, what I've done is I've included a package.json file. And if we open that up, you'll see that I have one dependency, which is this thing called browser sync. And it's really, really nice because it allows you to open up your website and start a little server. And it also gives you live reloading and a whole bunch of other stuff. So what I want you to do is type npm install. And if you don't have npm, if it tells you that's not something, you go to nodejs.org and download Node.js. So I'm going to type npm install. And when that has finished, what you can type is npm start. And what that is going to do, it's going to run this script that I have here. And this is just a really long browser sync start files. It just starts a little server for you. So npm start. And that is going to kick open a little server. It's going to tell you that your local server is 3001, and then it will also give you an external server in case you want to check it on your Wi-Fi, maybe check it on your Android phone, something like that. So I've got that up and running. Now let's go to our scripts.js, and I'm going to load in a couple selectors that we're working with here, just because you're probably sick of seeing me type selectors for now. Let's review them real quick. We've got this video here, which is a class of player, and if we look at our HTML, you'll see that we have a canvas, we have a video, and we have a strip. Now, the video from our webcam is going to come in hot off the webcam, and we're going to pipe that into this video element. And then every, 16 milliseconds or so, we're going to take a snapshot of that video and dump it into this canvas. Once it's in the canvas, we're going to manipulate the pixels, change the color, apply filters. We're going to have a lot of fun with that. But just know that the video is going to come off the webcam on the video element, and we're going to dump it into the canvas every so often. And then finally, the strip, that's where we're going to put all of our images. So That's what that video canvas context is, where the work happens. If you've never used Canvas before, go back to our Canvas tutorial that we've done earlier. We've got our strip, and then we have this audio, which is a little sound that's going to play every single time that we play a video here. Good. First thing we want to do is get the video being piped into that video element. So we're going to say function get video. And the way that you get someone's video, it's actually navigator dot media devices that get user media. And if you've done this before, you might have seen it as navigator.getUserMedia. It's now changed to navigator.media devices in some of the newer browsers, which is get user media. From that, we pass it the video, which we want to be true, and the audio, which is going to be false. Now that thing is going to return a promise. And we can, that from with a promise, we can call .then on it. It's going to give us something called a local media stream. And from there, we'll run a function. Let's just console log that local media stream. See what we've got here. So when you load it, you'll probably get a little pop-up here saying localhost would like to access your camera. Go ahead and click yes to that. And of course, we need to run this get video function on page load. And you'll notice it's refreshing automatically for you, which is a really nice feature. So here's what we've got here. We've got this media stream, and then we've just got some ID, active, true, and there's some stuff on the prototype that we're working with here. But really not much for us to deal with. So what we need to do is to take our video, and we need to set the source to be that local media stream. Now that's not going to work automatically because this is an object, and in order for our video to work, it actually needs to be converted into some sort of URL. This is a little bit weird because you might be used to having a video like a .mp4, but this is how you set it to be a live video feed. So we're going to wrap this local media stream in window.url caps.create object URL. And that's going to convert that media stream into something that this video player can understand. Finally, underneath that, we'll call video.play, which is going to play it. If I try it without, you might see like one frame. Yeah, see? One frame. And if you mouse over it, it will sometimes open. And why is that? Because we set the video to be this media stream, but it's not going to update unless we actually go ahead and play it. So I'm going to call video.play. And now, when you load the page, you should see yourself in the actual video element in the top right-hand corner that I've done here. If you inspect it, you'll see that the video source is a blob. And that just means that it's the raw data being piped in off this webcam right here. Last thing that we need to do is we need to do a catch here. Just in case someone doesn't allow you to access their webcam, we need to handle that error. So we'll say error. And when that happens, we're just going to console.error. Oh no, and then give yourself the error. And you could obviously tell the user, hey, you denied the webcam. Maybe you should not do that because we need to get access to your webcam. Good. So we are up and running with getting the video being piped in. The next thing that we need to do is to take a frame from this video and to paint it onto the actual canvas on the screen. So that's what we'll do here is we'll make a function. And we will call that paint to canvas. And we have a couple things first. What we need is the width and the height of the actual video. So say const width equals video.video width, and const height is equal to video.video height. Now, what we need to do is the video is going to have a width and a height associated with it. And if we were to call that paint to canvas, you'll see that it's 640 by 480. That's the size of the video that's coming in off my webcam. Now, we need to make sure that the canvas is the exact same size before we paint to it. And that's really important because if the canvas is not the same size as the video, or if your video webcam has a different width and height to it, then we need to change that. So we'll say canvas.width is equal to width, and canvas.height is equal to height. Good. Now, if you refresh and you inspect this canvas here, you'll see that right now it's 943 pixels. But if I were to call that paint to canvas, it will then be changed. It still shows me it because I'm stretching it with uh, CSS, but the width and the height have been explicitly set on the actual canvas. Now what we want to do is to every, I don't know, 16 or so milliseconds, we are going to take an image from the webcam and put it into the canvas. So we are going to set interval, and that is going to run a function every, let's start with 16 milliseconds. And you really have to play with how often is it going to paint to the canvas. On lower performance machines, sometimes you have to go up. You could also play with request animation frame, but I have had no success with that. So I'm sticking with an interval here. And we're going to take the canvas context. We're going to call draw image, and you simply just pass it your video element. So the way that draw image works is that you pass it an image or a video element, and it will paint it right to it. We're going to start at 0, 0, which is start at the top left hand. I guess you're on the other side here. Start at the top left hand corner of the canvas, and then paint the width and the height. And that's exactly why we stuck them in their own variables right here. So if we rerun that paint to canvas now, oh, we got an error. Set interval. It's capital I. Probably drives you nuts watching me code like that. There we go. And woohoo, what's going on here? Every 16 milliseconds, what's happening is this is our canvas element right here. And then up here, we've got our video element that we're working with. So we are taking a frame from it. And one thing I like to do is just return that interval here, because if you ever need to stop this from painting, you can have access to that interval and you can call clear interval on it. Good. Now what we want to do is let's work on the take photo function. So function take photo. And we are, let's work on the audio portion of it right now. So I'll say snap.current time equals 0. And we will say snap.play. So console, refresh. We want to go into our console and run paint to canvas. Got it going. And then we're going to run take photo, which should play. There we go. You might not hear it because it's not recording my computer's audio, but that should say ching, ching. Just imagine it going off right now. Good. So that is playing the photo. But before we go any further, it's kind of a pain to have to manually run this paint to canvas. So what we're going to do is we're going to go down to the bottom here. And we're going to listen for an event on the video element called can play. So we're going to say video.add event listener can play. That's an event that the video will emit. And when that happens, we are going to run the function paint to canvas. So what will that do? Once this video is played, it's going to emit, because we've got to get the webcam like sorted out first, right? Once the video is playing, it's going to emit an event called can play, which in turn, Canvas is going to say, oh, now we should start to paint to canvas. So that's going to now happen on our page load. Good. I'm happy with that. Now, how do we take a photo of this actual canvas here? So it's part of our take photo. We've already played the sound, which is not really anything to do with it. What we now need to do is take the data out of the canvas. And we can do this. Const data equals canvas.toData URL. And then you pass it image / JPEG or JPNG or whatever you're looking for. But it probably makes sense to do a JPEG with an E there, because it's a picture of me. It's not really a PNG. And then I'm just going to console.log the actual data, see what we're working with here. So I'm going to go to my console and see what we're working with here. I'm going to take a photo. Okay, and this is what happens. Whoa, what the heck is this? So what this is something called base64, and this is a like a text-based representation of the picture of me. So this like 8VPB4FB, that means like stunning smile. And this RVS0, that means like sweet baby blues. And these are just like little attributes about the photo in text-based form. So what we can do with that is we can create a link and an image to actually put it into our strip. Let's create a link here. So we'll say const link equals document.create element. We need to create a proper link here. You can't just use backticks. And then we will be creating a anchor link, and that link dot ref is going to equal the data. That's what we have there. Then we are also going to say link dot set attribute. The attribute we're going to set is called download, and we're going to set that to handsome. I'll show you why in just a second. And then we'll just say link dot text content equals download. And then finally, we are going to take our strip, which is where we're going to dump our links. We're going to insert before. We're going to insert the link node. It's going to happen right before the strip dot first child. That's sort of like if you've used jQuery dot prepend. This is how you do that in vanilla JavaScript. So what we did is we created a link. We set the href to, or href. Apparently href is not a word, but let's make it a thing. Dot set attribute dot text content. We've created the link and we've put it in. So let's see what we got here. It's running. I'm going to run the function take photo. Good. Now we have a link here that is download photo. I'm going to open it up in a new tab, first of all. And whoa, look what we got here. So the URL is just a data image here, but it's smart enough to know that that is the actual image. It's not anywhere on our computer. It's just stored in this really long text string. But what I also did is we made this download attribute of handsome. And when you click that, it's going to actually download it to your, there we go, download it to your computer, where it will then be put on your user's hard drive. And you can then open it up in your Finder, whatever it is you're using. There we go, handsome.jpg. Got it up and running. Cool. So we've got our download image. We got it. Now let's actually put the image visible inside of there as well. So rather than link.text content, delete that. We'll say link.inner HTML is equal to an image tag, and the source is going to be equal to the data. So both the href and the source is going to be equal to the data, and then we'll just say like handsome man. Adjust accordingly if you're not handsome. Then when we run take photo, there we go. You should see your actual photo. Every time you run that function, it's going to take a photo of yourself, and you can download any of the ones that you like. Cool. Let's hook it up to the actual button. So if we go to our index.html and we have this photo, it's already hooked up on click, or you could select it. I've just did sort of like a bit of a cheap way to do it without selecting it. And that button should now work regardless of whatever it is that you're doing. Good. So we've got our get video, we got our paint to canvas, we've got our take photo. Really, the last thing that we want to do is do some filters on them. So the way that a filter works is that you get the pixels out of the canvas, and then you mess with them, changing the RGB values, and put them back in. So let's go back up to our paint to canvas. Let's go into our interval, and we'll just do something like this. We'll say const pixels equals ctx.get image data, and then you ask for the 0, 0, the width and the height, just like we did before. And this might crash my browser, but I'm going to try console log it. It's going to be millions of pixels large, but let's see. Whoa, okay. So here we go. We've got this sort of special kind of array here, which is pixels.data. It's going to be a special kind of array that's meant for very, very large numbers. And if you open up one of those suckers, where did it go? Here, what if we do this? Console log pixels and debugger. Let's just stop it altogether. There we go. I paused it, go back to our console, look at some of this image data, open up the data. There we go. We've got 1.2 million items. And if you open up one of those and one of those and one of those, here's the actual values. Now, what is this? Well, 0 is going to be R, 1 is going to be G, B, are red, green, blue, alpha, red, green, blue, alpha. So this array here is simply just a huge array of numbers, which is the first pixel is red, the first pixel is green, the first pixel is red, green, blue. I can't even remember. And then the first pixel is alpha. And then it starts again. The second pixel is red, green, blue, alpha, red, green, blue, alpha. And it just goes over and over and over. So for every one pixel on this picture of me, you have 4 entries in your array that describe the red, the green, the blue, and the alpha. So what we can then do is we take this pixels, and this needs to be let because we're going to reassign the pixels array, not const. It wouldn't let us to do that. And we need to then take the pixels, say pixels equals, and let's do the red effect first. We'll say red effect and pass it our pixels. Then we go down here and we'll make our filter function red effect, takes in our pixels, and then you loop over every single pixel that you have. Say for let I is equal to 0, I is less than pixels.length. And if you're wondering why I'm not using .map here, it's because this is a special kind of array in JavaScript. It doesn't have all of the regular array methods that you're used to working with. And you say I equals I plus 4, or I plus equals 4. And that's just going to increment it by 4, not by 1. Don't put that colon there. Then we have access to our red, green, blue, and alpha, because pixels square bracket I is going to be our red channel. I plus 1 is going to be our green. I plus 2 is going to be our red, green, blue. And then we actually don't need to really mess with the alpha on this red effect on our own. So we say pixels of I equals, and then we can just start messing with it and changing with the red, green, blue one. So I'm just going to paste some stuff in here, and you can have some fun with it. So what I've done here is I've just said the first one plus 0. I've just added a 0 for so I can see that it's first, second, and third one that we have here. And I'm just equaling it to itself plus 100, second one minus 50, and the third one times 0.5. And there's no rhyme or reason to that. I just was messing with them, and some of them are going to go over 255 and some of them are going to go under, and that's totally fine. But what that will do is it'll give us a bit of a cool effect. What we do here is we return those pixels once we've done messing with the actual RGB values. And then we go back up here where pixels equals red effect. And then we say context dot put image data pixels 0, 0. And that's going to, we take the pixels out. Maybe we should put some comments here. Take the pixels out, mess with them, and put them back. So now if we refresh this sucker, I don't see a red effect happening here. Why is that? Let pixels equals. Let's just debug this real quick. We've got our pixels. We've got our pixels coming back. And we are putting it in. Any errors in our console? Nope. Here is our one. Returning our pixels. I'm not sure. Oh, I figured out what it was. Our loop is pixels.data.length because pixels is not an array. Pixels.data is an actual array. So now if I save that, there we go. Now I've got this bit of a red effect going on here, and we're seeing all of the different colors being changed. And if you were to mess with this, like minus 100, you see you get a bit of a different color effect, or plus 200, it will just jack the red up really as high as we can go. So that's the red effect. Next up, what I want to do is what I like to call the RGB split. So let's say function RGB split that takes in our pixels. And we're going to do exactly the same thing that we did here. So you can just copy and paste these values into here, except with our RGB split, what I'm going to do instead of just changing each individual one is I'm going to take the red and change the one that is 150 pixels back to be the current color. And I'm going to take the green and take the pixel that is 150 pixels forward and set it to be the current color. And then I'll do the same thing with the 150 uh, pixels for the blue. So I'm essentially just pulling apart the different red, green, blues, and I'm moving them to either side so that when we're working with it, we're going to be able to see the different ones that we're working with. So I'm going to take that RGB split function. I'm going to comment out this pixels one, and I'll use this one. Pixels equals RGB split pixels. And now when you refresh, you should see your red, green, and your blue channels sort of showing up where we have it. And I think we could go down here and maybe change this one to like 550 maybe. I don't know. I'm just there we go. You see the blue, my face, which is blue, is like totally, it's 550 pixels off. And then if I get to the edge of the screen here, it starts to wrap around to the other edge of the screen, because at a certain point, if the pixel's on the very left-hand side, it's going to wrap around. And of course, you can play with this, make this 500. Whoa, that's way more fun. I really like that. And then I also figured out that if you go up right here and you take your CTX global alpha to be 0.1, what that's going to do is it's going to write the actual one that we have, but the ones that are underneath it are still going to show through for 10 more frames. And the reason that is because we're just like putting a transparency of 10% of the current image on top, and we're just stacking and stacking and stacking. So as it goes, it sort of like follows you around, and you could make that 0.8 and it would still be ghosting, just a little bit less of an actual ghosting effect. Ooh, that's really, really fun. Cool. Last one up, we want to work with the green screen. So we're going to go in here. I'm going to have a function called green screen. That's going to take in our pixels. And again, I'm just going to take this from the answer here and explain it to you, because there's a whole bunch of stuff that's going on here. And so I pasted it in here. First of all, we've got this levels object here, and that's going to hold our minimum and maximum green, because the way that green screen works is that you say, give me all the colors in between this RGB value and take them out. And usually that's like you find a certain like range of special greens, and then you take those ones out, and they don't occur in the people's clothing and whatnot. So we have started with some blank levels. Then I've grabbed every single RGB input, and actually this conversion to array is no longer needed. So that's all 6 of these sliders here. And then I've set the red min, red max, green min, green max, blue min, and blue max to be on that. So if we were to console log the levels, and we were to go up here, take off the RGB split and the alpha, and say pixels equals green screen pixels. I'll check out our console here. You see that we've got these objects happening, which is going to give us the red min, red max, et cetera, et cetera. Okay, good. Then we have a huge for loop, just like we've done before. We loop over every single pixel. We figure out what the red, the green, the blue, and the alpha are. And then we say, if the red and the green and the blue and the red and the green and the blue, if it's anywhere in between those min and max values, that's what this huge if statement does. We take it out. Why? Because the 4th pixel is the alpha, which is the transparency pixel. And if you set that to 0, that's going to be totally transparent, rather than 255, which would be totally there. So if we give that a save now, and you play around with these sliders now, you can just change your min and your max red, green. And if you have a bit of a green screen, or I've done it before where I got a pink Bristol board and put it behind me, and I found that slice of the rainbow where we want to pull that specific pink or blue out. In this case, I'm just pulling out random colors that seem to match, and it's kind of fun to work with. So that is it. That was a big one. I know that I went a little bit fast, but this is one where I want you to go back and just play with it. Start to make your own filters. Now that you understand that it's just a huge array of color values, and especially if you understand how color and math relate to each other, you can start to make some really cool, fun filters with them. And I'd love to see any of the filters that you do make. Thanks a lot. And guess what? I will see you tomorrow.